Hi everyone, this is Chandan and you're watching the learning field. So I take this class after a long time because of some reason, and this is the class on WBSET 2023 December paper discussion. And in this session or in this class, we will discuss the questions of linear algebra, the questions of LPP, and the questions of fluid mechanics. Fine. So one is from pure mathematics and two topics are from applied mathematics. So 5 to 6 questions, I think 6 questions is from LPP, two questions are from LPP, and 2 questions are for fluid mechanics. So I already uploaded many of the videos of WBSET PYQs. Okay, you just go to my channel and find the playlist. In the playlist section, you just get the playlist of West Bengal set, because West Bengal set date is finalized. It is 15th of December 2024 and admit card has also released. Fine. So admit card has also released. Fine. So admit card released and question and exam date is on 15th December 2024. And these are the PYQ sessions of West Bengal set PYQs, and more videos are already available in my channel. You can go to the playlist of West Bengal set mathematics and find the see the videos or lectures for your questions practice and your previous year questions. Fine. So let's start this class. So first question is this one. So it says that let A and B be two real n by n matrix such that date of AB not equal to 0, then which of the following is true? So here 4 options is given. Now this is a very easy problem if we choose the two matrices A and B very easily. So always think about the easy to easy matrices about for example. See here A and B are two real matrices. This is only the statement given. It is not given that A and B are distinct. So we can choose A equal to B equal to I. Fine. So AB equal to BA equal to I. Fine. And it is say suppose 2 by 2. Suppose this n by n, suppose we choose n equal to 2. Fine. Because of our to solve easy to solve the problem very easily. Fine. So I 2. Okay. See now AB and BA have same characteristic polynomial, but if AB equal to BA equal to I2, then A and B both have same characteristic polynomial. This is discarded. AB and BA have different Jordan canonical form. This is also discarded. And then AB and BA are different minimal polynomial. This is also discarded, because if AB and BA are same matrix, then the characteristic polynomial or minimal polynomial or Jordan canonical forms are also same, because this is only one matrix. This is an unique matrix AB for both the case of AB and BA. That's why answer C is correct here. Next question. So this is a question says that let A and B be any two n by n matrices and trace of A equal to this, trace of B equal to this. There are the definition of traces are given here. So following statements. So this is very basic question from the properties of traces. So there are two properties of traces are given in the problem. So you all know that there are three main different properties of the trace. So find for a matrix A, so lambda into trace of A, this is trace of lambda, this is one. Number 2 is trace of, for two matrix A and B, trace of AB, this is equal to trace of BA, this is also a property BA. And number 3, trace of A plus B is equal to again trace of A plus trace of B. And one more thing I am discussing here, that you always remember that trace is always following the cyclicity property. If there are three matrices, suppose A, B and C, then you just write the matrix A, B, C in this cyclic order. Fine. And you just have given that trace of A, B, C equal to what are the processes of, or what are the forms of this we can write here. So trace of ABC equal to trace of BCA, trace of CAB. We also write these two terms. And for matrix A, B, C, D, you can also process this cyclicity order A, B, C, and D. If we write, then trace of ABCD equal to trace of BCDA equal to trace of CDAB equal to trace of DABC. We can write these things. So these are the important properties regarding trace. That means this statement 1 is also true statement, and this statement 2 is also true statement. That is, which of the following option are given correct? So option A only no, option 2 only no, both option 1 and 2 are correct here. Fine, and this is not incorrect. Now, and one more thing is that those who are watching my channel, if you get any help from my channel, then don't forget to give or don't forget to subscribe my channel. Okay, don't forget to subscribe my channel and hit the bell icon you see here. Fine. Now, next question. This question says that let AB be to complex n by n matrix. Consider the following statements: A, B, and A plus B are invertible. Then A inverse plus B inverse is also invertible. Fine. So A plus B inverse is also invertible. Number 2 statement: if AB is nilpotent, then B is also BA is also nilpotent, and this option. So it starts with statement number 3. Fine. So A plus B inverse whole square. This is equal to, we can write A plus B inverse into A plus B inverse. Fine. So this is equal to A square plus A B inverse plus B inverse A plus what? B inverse whole square. And this is you given here A square plus B inverse whole square. But this term vanishes here. But you don't say that this term A B inverse plus B inverse A, this is equal to 0. This is equal to 0 matrix. If this is possible, or if this is whole, and if there is any properties given in the questions, or there is any hint given to which you can show that this term is equal to a 0 matrix, then obviously this equality holds. But this equality is not holds in general. Therefore option 3 is not correct. Now options 2 state that if AB is nilpotent, then BA is also nilpotent. Now what is mean by a nilpotent matrix? Suppose a matrix A is said to be nilpotent, then we write it as A to the power k equal to a 0 matrix, or k is an positive integer. K is a positive integer. Fine. We say that this k is the index of the nilpotent matrix. Now if we start with AB is nilpotent, that means AB to the power some k, this is equal to 0, where k belongs to Z class. Fine. Now if we write AB k times, this implies AB into AB into AB into AB. This is k times, this is equal to 0 matrix. This is k times. Fine. Now if we multiply left side by B and right side by A, then this gives B into AB. Okay, then AB, then AB into this A, this is equal to B into 0 into A, and this is again a 0 matrix. This is a 0 matrix. Fine. This is a 0 n by n order 0 matrix. So now we can write this BA, this is as BA, then again BA, then again up to BA. Last term is also BA. This is equal to again 0. So this implies BA. How many BA? So BA to the power k plus 1. This is equal to 0. See, there is k AB term, and if we multiply 1B and 1A in the left side and in the right side, then this becomes a k plus 1 term in BA format. So this is equal to 0. This implies this BA is also nilpotent, we can say. Fine. So AB is nilpotent implies BA is nilpotent. That means this statement is a true one. Now if AB and A plus B are invertible, now if A is invertible, That means suppose this n by n is, suppose we take n equal to 2, then the eigenvalues of A are suppose lambda 1 and lambda 2. Therefore the eigenvalues of A inverse are 1 by lambda 1 and 1 by lambda 2. Suppose this lambda 1 and lambda 2 not equal to 0. Fine. So eigenvalues of B, this is equal to, again if we take mu1 and mu2, then eigenvalues of B inverse we all know that 1 by mu1 and 1 by mu2. Fine. And mu1 mu2 not equal to 0. It says that A plus B is invertible. That means what? Det of A plus B is non-zero. And since A and B are two square matrix, then we can write det of A plus det of B equal to 0. Not equal to 0. If we write or no, I think this is not the property. So A plus B is invertible means these eigenvalues of A plus B are what? A plus B are eigenvalues of lambda 1 plus mu1 and lambda 2 plus mu2. Fine. Now eigenvalues of A inverse plus B inverse are what? So these are non-zero eigenvalues. These are non-zero. These are non-zero. Now A inverse plus B inverse, eigenvalues of A inverse plus B inverse, this is equal to 1 by lambda 1 plus 1 by mu1, and the second one is 1 by lambda 2 plus 1 by mu2. Fine. So these two are non-zero because of, if we write lambda 1 plus mu1 by lambda 1 mu1, since this lambda 1 mu plus mu1, since AB is not invertible matrix, AB is invertible, therefore lambda plus mu not equal to 0 eigenvalues, and lambda 2 plus mu 2 also not equal to 0. Therefore this lambda 1 plus mu 1 is not equal to 0, and lambda 2 plus mu 2 by lambda 2 mu 2 is also not equal to 0 because of lambda 2 plus mu 2 is a non-zero matrix. Therefore these two are non-zero matrix, non-zero eigenvalues. Therefore A inverse plus B inverse is also invertible. Fine. So this is also a true statement. Fine. So option A 1 and 2 are true statement here. So this option A is correct one. Fine. Next question. Fine. So the next question is this one. Let A be a 3 by 3 real matrix having eigenvalues 1, 0 and 1. Fine. So eigenvalues of A are 1, 0 and 1. Therefore eigenvalues of A to the power 2022, this is the properties of eigenvalue are 1 to the power 2022, 0 to the power 2022 and 1 to the power 2022. That means eigenvalues of A to the power 2022 are 1, 0 and 1 again. Fine. Now eigenvalues of I plus A, because of eigenvalues of I are 1, 1, 1. Therefore eigenvalues of I plus A are 1 plus 1, 0 plus 1 and 1 plus 1. That is eigenvalues of I plus A are 2, 1 and 2. Therefore determinant equal to, we know that the determinant means product of eigenvalue. Determinant means product of eigenvalues. Therefore product of eigenvalues of I plus A, determinant of I plus A equal to 2 into 1 into 2. This is 4. Fine. This is option A is correct one. Next question. Question number, this is 61, and one more thing is that this all questions paper number are from X series. Fine. X series of West Bengal set exam. So let's see with the field of complex numbers, then the vectors alpha and beta in V2C and two-dimensional vector space over C are linearly dependent if. Now how can we check that the linearly dependency or independency in matrix form? So if we write this alpha equal to, because A1 A2 and beta equal to B1 B2, these are two column vectors and these column vectors are linearly dependent. That means what? If we write the determinant form A1 A2 and B1 B2, then this determinant must be 0. Now this determinant 0 means what? A1 B2 minus A2 B1, this is equal to 0. Fine. So what? This is very easy questions. Okay. Option number D is correct answer. Fine. Also you can apply this by, suppose there exists scalar c1 and c2. Linearly dependent means what? Linearly dependent means we can write c1 c2 both are non-zero, so that this c1 alpha plus c2 beta, this is equal to 0. Fine. So c1 equal to c1 alpha means we can write a1 a2, and beta means c2 into b1 b2, this is equal to 0. This is the definition of linearly dependence, where c1 and c2 not both 0, in case not both 0, not both 0. Fine. So this can we write c1 a1 plus c2 b2, this is equal to 0. From this we can write this, and c1 a2 plus c2 b2, this is equal to 0. See, this c1 and this is two equations in two variables a1 and a2, and the unknowns are two unknowns c1 and c2. Therefore if these are what we say, from this we can write c1 sorry a1 by a2, this is equal to b1, sorry this is b1 by b2. You can also write from this a1 b2 minus b1 a2, this is equal to 0. You can also think about this way. Fine. Since these are two lines, and since they are linearly dependent, that means I think this is the condition. You just comment me if you have any doubt or not. Okay, I think this is the condition. So next question, this question is from LPB. Fine, this question is from LPB. So question says that the set x1 x2 or x1 greater equal to 1 and x1 greater equal to x2 is a convex set, is not a convex set, bounded set, and not a convex set. First of all, see, x1 greater equal to 1 and x1 greater equal to x2 means this is not a clearly bounded set, so we can discard option D. Now we can check whether it is a convex set or not. Now what is the definition of convex set? This is you have to know first. So if, what is the definition of convex set? If suppose S is a set, suppose we take S equal to this x1 x2, fine, so that x1 greater equal to 1 and x1 greater equal to x2. Now if we take two elements from this S, suppose x is a vector equal to x1 x2 and y is an element from S, y1 y2, this x and y belongs to S. We have to show that what lambda x plus, these are vectors, okay, these are vectors, lambda x plus 1 minus lambda into y, this is also belongs to S. If this belongs to S, then we say that this S is a convex set, so where 0 less than lambda less than 1. Fine, this we have to show. Now if we choose this x1 and x2 from S, then what we get, x1 greater equal to 1 and x1 greater equal to x2 for this x, and now for y, y1 greater equal to 1 and y1 greater equal to y2. Fine. So since x is an element of S and y is an element of S, then this followed, because this is an element of S. How this element was? This element was x1 greater equal to 1 and x1 greater equal to x2. Now lambda x1, lambda x plus 1 minus lambda into y, this is equal to what? Lambda x means lambda into x1 x2 plus 1 minus lambda into y1 and y2, this is equal to, you can write lambda x1 plus first element add, so we add first element from of this and first element of this, plus 1 minus lambda into y1, this is one element, and the second element is lambda x2 plus 1 minus lambda into y2, this. So these are the two elements. Suppose this is we take x and this is we take y. So we have to show that what, x is greater equal to 1 and y and x is greater equal to y from this definition of the set. If we have to show, or if we show, if this holds, then we say that This set is an what? Convex set. Fine. Now we start from here. We start from lambda x1 plus 1 minus lambda into y1. This is equal to see, since this holds x1 greater equal to 1, so since lambda is greater than 0, therefore there is no problem in this inequality. So lambda, we can write, since x1 greater equal to 1, we can write this is greater equal to lambda plus 1 minus lambda. This is also positive quantity, and y1 is also greater equal to 1. Therefore we can write this thing. So this means what? Simple 1. Therefore lambda x1 plus 1 minus lambda into y1, this is greater equal to 1. Therefore first condition hold. This is the first condition from here. The first element is greater equal to 1. I think you will understand that x1 greater equal to 1. This implies, since lambda is positive, lambda x1 is greater equal to lambda. We write here, and the second one is 1 minus lambda into, since y1 is also greater equal to 1, so 1 minus y1 is greater equal to 1 minus lambda. So this inequality 1 holds. Now check the second inequality. The second inequality is that lambda x1 plus 1 minus lambda into y1. Now since x1 greater equal to x2, therefore we can similarly write this is lambda x2 plus 1 minus lambda. Since y1 greater equal to y2, therefore we write greater equal to sign y equal to y2. Therefore these two conditions holds. This is the second condition, this is the second condition, and this is the first condition. Okay, so these are two conditions, first and second. So these two are holds. That means this is clearly a convex set. Fine, this is clearly a convex set. Option A is correct answer. These are very nice questions from LBB made this year. And now question number this one, 64. The dual of the linear programming problem, minimize C transpose X subject to Ax greater equal to B and X greater equal to 0. That means what? Now what is, we all know that for if we change a primal problem to a dual problem, what is that? Ith constant less equal to type. This implies ith constant less equal to type. This means ith variable greater equal to 0. Number 1. Number 2, equal to type. Ith constant equal to type means ith variable unrestricted in sign, and if ith variable is greater than 0, ith variable is greater equal to 0. This implies jth constant is greater equal to type, and if jth variable unrestricted, then this jth constant is equal to type. We all know that. But there is all greater equal to 0, therefore there is no problem in the variable. So this is a minimization problem, therefore the dual must be is a maximization problem. So all problems are maximization. Fine. Now this is greater equal to type, therefore the constant must be of less equal to type. So this is given greater equal to type, incorrect. This is greater equal to type, incorrect. Fine. Now it is a all x are greater, x means greater than 0, means x is a vector, column vector, all x are greater than 0. Therefore no w is unrestricted in sign, but here it is given that this is unrestricted. So this is also incorrect. The correct option is option B. And you all know that if minimization of C transpose X subject to Ax equal to X greater equal to B, then the maximization problem, that is the dual of this problem, is maximization of B transpose, this B transpose to here, B transpose another dual variable W, and subject to A transpose this matrix transpose, and comes to here A transpose W is less equal to C. So this is that by definition. Okay, so this is question number 64 and option B is correct answer. Next one. And there are two questions of fluid mechanics. So it says that in a fluid flow, which of the following have the same forces acting on them? So I think this question is quite incomplete, because this them it stands for what? So you have to know this them it stands for two things in fluid mechanics. One is one is model and prototype. In fluid mechanics, this them means model and prototype. Fine. Now, dynamical similarity means what? First, we know what is kinematic similarity. Kinematic similarity means motion of the model. Motion of the model is, you must define or see this four definition or three definition. Motion of this model is similar to motion of the prototype. Fine. This is kinematic similarity. Now geometric similarity means when the ratio of all corresponding linear dimensions are same in the model and prototype. Fine. This is geometric similarity. And dynamic similarity means the forces acting on the model and prototype are same. ठीक है. So these are the three definitions. This is dynamical similarity. Forces acting on them are same or same in ratio. Fine. Same or same in same ratio. Same or same ratio. Fine. Then this is called dynamic similarity. And here it is given that the same forces acting on them. So this is clearly the definition of dynamical similarity. Fine. And conditional similarity is not related to these fluid mechanics topics. This dynamical, I think this conditional similarity is not a term of fluid mechanics. Okay. This is to create an options. I think this is given. So motion, when the motion in when motion means what? Suppose motion means what? Velocity. Suppose one of its is velocity. Suppose the velocity of the model is similar, or the velocity of the model and the prototype are in same ratio, then it is said to be kinematic similarity. Geometric similarity means the dimensions, the ratio of the dimensions of the model and the prototype. Suppose there are linear dimensions in suppose, what can we say, suppose this is the flow is two-dimensional for prototype, therefore this is similarly a two-dimension in model also. So this is called the geometric similarity. Fine. And kinematic similarity, all are defined. So this is the correct answer, dynamic similarity. Fine. Next question. This is the last question of today's class. So the characteristic of the ideal fluid is, so you must remember what is ideal fluid. So in the I think lower class we all know that ideal gas means what? The gases who are obey the ideal gas relation, that is PV equal to N RT, where N is the constant. If this equation obey, then a gas is said to be ideal gas, and gas is nothing but one type of fluid. Fine. Fluid dynamics means gas, then liquid, then plasma, all the generalization of this is fluid mechanics. Fine. So you remember the ideal fluid. Ideal fluid means there is no actual fluid. In general, there is no fluid is ideal. No fluid is ideal in our reality. Okay. So the properties of ideal fluid is number one is there no viscosity. Ideal fluid has no viscosity. Fine. Number two is they are incompressible. Incompressible. Number three is what? They are irrotational. Irrotational. Fine. So what they these three term means viscosity, and number four is no surface tension. No surface tension. Fine. So no viscosity means what? There is no internal force. Viscosity means no internal force. Fine. No internal force. Incompressible means if pressure change, then velocity or the volume is not changed. For liquid, incompressible example of incompressible fluid is liquid. Sorry, yes, liquid. If we change the pressure, then the volume does not change. This is incompressible fluid. The definition of incompressible fluid. And irrotational means there is no no movement of the articles about their center of mass, about their the center of mass. Fine. So irrotational means there is no movement or no velocity or no movement of each fluid particle about their center of mass. So these are the four properties of an ideal fluid, but in real world there is no fluid which is ideal. Fine. So it says that it is compressible, no. Forced vortex flow, this is no forcefully flow. And one more thing is that ideal fluid means they are steady flow and uniform flow. Means dx dt, if x is the fluid velocity with respect to time, then dx dt equal to constant. Fine. Dx dt equal to constant. So the viscous in nature, but it says that it is no viscosity. Discard. Force vortex flow, no, there is no forcefully flow, and fluid velocity is uniform. This is the correct answer. Steady flow and uniform flow. Uniform flow means the velocity is same in any time, and steady flow means dx dt equal to constant. If x is the velocity at time t, then dx dt equal to constant. Fine. I think this is the sufficient explanation for this problem. Okay. So these are the total questions of today's class. One is linear algebra, second one is LPP, and third one is the fluid mechanics. Fine. So if this video is helpful for you, then please give a like to this video, share with your friends, and subscribe the channel. Okay. Thank you. Bye. And if you have any comment or if you have any doubt, then you can definitely comment in the comment section below. Thank you.